All right. Okay, so we are about to start. The last email has just been sent, and we will start at 1 minute.
No problem.
Okay, cool. Is this? It's ringing. Let's go.
Oh, okay. Click start. Hello everyone, my name is April from Be My App and welcome to today's webinar. Luca Mezzalira is a solutions architect, a Google developer expert on web technologies and manager of London JavaScript Meetup. Today he's going to talk us through how to build a better front end. Please note, if you have any questions, please write them in the comments section and Luca will address them at the end of his talk. That's it from me. Take it away, Luca.
Hi everyone, and thanks for joining me. Okay, so let me first share my screen so we can start this talk. Okay, I hope that you can see my presentation. Cool. So let's talk about next generation front-end architectures. So I think that you already know who I am. Thanks for the introduction, by the way. Today we are going to cover a few things. So we are going to talk about the current status of the front-end architectures. We are going to talk about communicating sequential processes. Then we are going to talk about transducers. Reactive programming, that is quite an hot topic right now, and one of the architecture that currently are well known in the reactive movement, that is MVI, and we will see later on what it stands for. So let's start with some discussion around what is the current status of the architectures. So I prepared this slide, and usually I think it raises quite few success in the past few talks that I did, because I would like to show you how we evolved the architecture of front-end, not only front-end architecture, but in general architectures from the 80s to nowadays. I think that everyone knows what MVC is. So model view control is quite famous, was created in the 80s. Is it implemented, I would say, in the vast majority of the application that we have seen until now, and still is quite a popular architecture, also, if not in production, also for prototypes. Model view control is basically based on a model where we are storing all the data. We have a view where we are visualizing the data to the user, and the controller that basically does what it says. So basically it's controlling the application, so it's the glue between the model and the view. This let's say pattern was implemented in several ways. Some languages are implemented in a way where the model and the view doesn't know each other, and some other languages are implementing this architecture in a way that the model and the view knows each other. So every time that there is a change inside the data in the model, the view is reflecting these changes without passing through the controller in order to update itself. And then later on in the 90s, so after more or less 10 years, there was a new architecture that came up, and that is called MVP, so model view presentation model, where the main difference is, in this case, the presentation model basically is tied one-to-one with the view. So every time that there is a view, there is always a presentation model. And the interesting part is the presentation model is fetching all the data, data from the model that needs to populate the view. And the other interesting part is that the presentation model has quite a good knowledge of what the view should do, and the view is just a passive view, how it's called. So the passive view basically is just a view that is rendering some data and giving some interaction from the user to the system. But again, it's just something that is used to interact with the application. The view is, in this case, is dump. And it's very interesting because this pattern allows you, in particular, if you work in an application where you have to target different devices. And when I mean different devices, I mean like not only smartphone or tablet, but also smart TV or other devices where, I don't know, your JavaScript code or your front-end code is running. You can have, at compile time, you can swap the view, in particular if you're using tools like Babel or, I don't know, Hex or other programming languages that allows you to swap classes, and you have conditional compilation as main feature. In this case, the model is a model that is keeping the state for the whole application. And again, the presentation model is tied one-to-one with the view. It's interesting when you want to work in application that runs multiple targets, and you have to have quite good control on the views. And then in 2005, Microsoft changed a little bit the way how MVP was raised up, creating an MVVM that stands for Model View View Model. In this case, again, model and view remains exactly the same, but we have something different. We don't have a presentation model anymore. We don't have a controller, but we have a view model. A view model basically is a sort of controller that inherits all the benefit of the presentation model plus the benefit of the controller. In fact, the view model basically is in the middle between the view and the model. The interesting part is the view model can control multiple views. And also, it has a unique way to update the data inside the view, where instead of calling like a presentation model, a method, public method exposed inside the view, is used to use a binding. So basically, there is a variable that is injected between the view and the view model, and is updated accordingly every time that there is something that is changing inside the view, inside the model. Sorry. This is very famous, in particular, if you're used to work with Angular 1 or if you're used to work with Knockout.js. And then in 2009, the creator of MVC came out with a different architecture. It's not very famous like MVC, but it's worth to mention. It's called DCI, Data Context Interaction. And in this case, the main difference is that is approaching the architecture in a completely different way from the previous architectures. In fact, DCI is called the lean architecture. And it's interesting because for the first time here, we are thinking more about how the business will structure the application more than how a technical team should structure the application. In fact, basically, we have data, context, and interaction. So we have some actors that are interacting with data inside some context. And usually the context is the glue where the data and the actors that are completely agnostic each other are interacting with themselves. I would suggest to check the website of DCI because you can find really a lot of good insight. In particular, if you are a big fan of domain-driven design, I think this architecture would suit perfectly your need. After that, in more recent time, Facebook came out with an interesting design pattern called Flux. Flux, as you know, is a framework that was created to give some structure or when you want to work with React. It was immediately interesting because it was leveraging a very important concept that is basically the concept of unidirectional flow. In fact, with Flux, what you're doing is you know exactly where the problem could be inside your code base, mainly because you know that the flow is always the same. So you know that if a user is interacting with the button, the view is dispatching an action. The action is brought by the dispatcher, and then there is an update on the store, and the store update the view, and it's always in the same way. So there can't be any other way to that the flow of the application is going. So it's super easy, in particular if you have a large team, to jump inside the code and understand straight away where to put your hands in order to fix a bug or implement a new feature. And then in 2015, there is a very important person in the reactive movement that is Andreas Statz, that started to speak about MVI, model view intent. And we will take a look more deeply to this architecture later on in this talk. Okay, so which is the main challenge that we face every time that we work with this architecture? Event-driven architecture are very interesting because are giving you a lot of flexibility when you work together, but sometimes it's tough to follow all the communication across these different objects, because obviously it's based on events, and because it's very decoupled, this system, it's hard to follow sometimes the whole flow of your events. So recently, like a year ago, more or less, I started to study more deeply how or if there are any alternative way to work with this event-driven architecture. And I discovered that there was this thing, CSP, that it's not really a new concept. CSP stands for Communicating Sequential Processes. It was created in 1978, so it's quite old, more or less the same time when MVC was created. There is an interesting port in for JavaScript. That there are several of them, but I think the most effective one is CSP.js. That is supporting from Clojure, and in particular is taking inspiration from the Core Async library and from Go. In particular for the Go routine. It flavors the composition over inheritance. That is definitely a good concept for if you are interested in OOP. And this leads to create easy. It's super easy to test any system that is based on CSP. It's loose coupled and well encapsulated, so it basically it has all the benefits of working with a good OOP structure. It's very interesting, a different approach from what we have as usual. So just to give you a brief idea how you could work with CSP. CSPs are leveraging the idea of channel. And it's slightly misleading sometimes, the name, because it's communicating sequential processes, but you can communicate also parallel processes. So you can, let's say, broadcast a specific notification at the same time, so in parallel, to multiple channels. So it's misleading a little bit, but it gives you a lot of flexibility of what you can do. The interesting part of this is potentially, usually when you communicate with a controller, representation model, or I don't know, directly with a model, or whatever you use to communicate with the view, for instance, and you usually, I don't know, or inject the view inside the controller representation model, or you use event in order to decouple, or you use mediator. So there are several ways that you can interact between objects. Another interesting way could be the channel. CSP is leveraging this concept of channels, where basically you can interact between two entities, two objects, through the channel. So in this case, for instance, the controller and the view, they don't know each other at all, and they communicate only through a channel. And the interesting thing is the channel is not just, let's say, a place where I put some data and retrieve some data, but it's also a place where I can create some logic inside, and we will see in a bit. So in order to explain a little bit further this concept, I prepare this small example. Let me go to my code base. Let's start the example first, so I can show you how it works here. Okay, cool. So what I have created basically is a bingo system. So a bingo system is basically the game of bingo, where you have some tickets, the user has some tickets, and there is an engine that is calling some number. In each ticket, there are 15 numbers, and basically the engine is calling, if I remember well, something like 40, 50 numbers per game. Every time that there is a call, basically what we are doing is checking if the number is present inside the ticket, and if it is, we are dubbing. So we are just saying yes, there is this number. So for instance, we have a ball called 50, that is the engine that is calling this number, and the ticket T1, that is the first one, has the number 50. So and so on. So as you can see, every now and then the engine is calling a number, and I'm checking if inside my ticket this number is present. At the end, in order to win the game, obviously, I need to have a specific pattern inside the ticket, or a certain amount of numbers that were called by the engine. So let's see how I have implemented that with CSP. So as you can see here, basically my application is doing this. So I'm initialize my application, doing three things, basically. Creating the channels that will be injected inside the different the view and the other object in order to communicate. I obviously wire the channel together, and I create the bingo system. So when I create the channel, basically what I'm doing is just creating three channels. And then what I'm doing here, that is very important, I do exactly what I explained before. So I basically say there is a channel of these three, that is the channel that will be injected inside the main engine of the game, that is basically broadcasting the notification to two different channels. And in order to do this, I use the library that I explained before, CSP.js, that is doing basically csp.operation.malt. I said which is the channel that I want, that is the base channel to broadcast. And then I say, okay, basically I want to broadcast from this channel to another channel. So basically I'm creating a system that is creating a context of the game, and they are wiring my channel together in order to be broadcast. So as you can see here, then, when I create the real bingo system, I created the ticket, another ticket, and then I created the ball call. The ball call system. The ball call system is basically our engine. Let's see what we are doing inside the ball call system. Inside the ball call system, we are injecting the channel. So basically, I'm using the advanced injection in this case in order to work with this. I'm doing a total of 40 calls inside my game. I generate randomly some 40 numbers, 40 unique numbers from 0 to 99. And then every 3 seconds, basically, I'm calling this method. And in this method, what I'm doing is just putting inside the channel, so inserting inside the channel one information, that is the ball that was called. And obviously, I increment a counter that is checking when the game is finished. So this is basically how the game works. And what I'm doing, basically, every time that I put this information inside the ticket, as you can see, there isn't any reference inside the engine of tickets. I'm just talking about channel. Inside here, that is the ticket object, I'm basically generating 15 numbers in this case, unique 15 numbers. And then what I'm doing here is using a coroutine. The coroutine in JavaScript is a new feature that is provided in ECMA 6. I would suggest to take a look. It's interesting because inside the coroutine, you can stop the function and then resume when you need it. So in this case, I'm doing exactly this. So until the channel is not closed, I'm basically checking every time that there is a call inside the channel. I retrieve the value. And basically what I'm doing is retrieving the value. I retrieve this value inside the channel, just saying yeah channel, and I retrieve this information. And when I do that, I check if the value is corresponding to an existing one that I have inside my array through this if statement. And then I can say, okay, if there is got a number, so I trace inside the console that I found a number that is existing. As you can see, these two objects, ticket and ball code system, they don't know each other at all. The only thing that they are communicating through two other different objects that are two different channels that are expressed inside here, the application. So there is basically, when we wire the channel, there is a communication between the ball code channel and the ticket. And that's it. So the objects are completely separated. It's super easy to test them, and also it's very easy to if you want to change your mind or increase the functionality of the application, you can do that very easily because you don't have any couple between the system. The only couple that you have is just a communication one that is defined in these 3 lines of code. Okay, so let's jump to ahead with our presentation. And okay, so what you can do with the CSP library? So you can set a buffer inside the channel. So you can say, for instance, I want to store inside my channel always 3, 4 elements. You can retrieve data from the channel. You can insert data inside the channel. You can close a channel, or you can close a channel after a certain amount of time. You can insert an array of data instead of just a primitive value, a primitive variable. You can I don't know, split, merge, or pipe the channel. So that's interesting because you can, for instance, say, okay, now I need I have one unique channel. I want to split up because I'm creating 2 objects. I can do that, or I can merge back the 2 channels in one unique one. I can create a pub subsystem. That is something that is very interesting because that means when you need to communicate across the entire application and you don't want to insert a specific channel that are used to communicate across the whole application, you can use a pub subsystem on top of the channel communication, where the channel are handling the communication between 2 objects that are very close, and the pub subsystem are updating the state for the whole application. You can broadcast values simultaneously to multiple channels, and then there is the interesting part, the transducer part. So you can map, filter, remove data inside the channel. You can avoid duplicate data, and you can decorate data. Let's see what a transducer is. That is very important, this concept. So transducer stands for transform and reducer. And transform is basically producing some value from a first one, the initial one, and the reducer instead is combining value of a data structure to produce a new one. So as you can see inside the channel, you can use this thing, so the transducer, in order to apply some transformation of the data directly inside the channel. If you think what could be a good use case, I would suggest this one. So for instance, let's assume that we are creating a stock option dashboard, where basically we want to achievate the user showing the value in his own currency. So let's assume that all the data that we retrieve from the server are in dollars, and the user is based in I don't know, in England, and we want to show this data in dollars, but also automatically the translation in pounds. In order to do that, you should apply a logic that should rely on the view or on the controller. But to be honest with you, it's not correctly there, because you can also apply this logic on the model, but you really need to store this information inside the model. I don't think so, honestly. So one place that could be very interesting to place instead is a transducer. So basically inside the channel, you can say that every time that a controller is pushing a value inside that channel, the channel itself is transforming this information in keeping I don't know, the dollar and also the dollar symbol, and also adding the transformation in pound. And that leads to have a very interesting way to handle data, because then you can reuse the channel in different parts of the application without rewriting code. Instead, if you use views or controllers to store this information, it will become a lot of duplication around your application, in particular if it's a large one. And if you decide to store this data inside the model, it's not completely correct. So I think the channel in this case could be a good use case with transducer. So again, is applied at the channel level, so you can keep raw data and inside the model or presentation model, and inside the view is just rendering, so it's doing exactly what it should do. After that, after the CSP, I started to study and spend more time on reactive programming. Basically, CSP, I can say that is the ancestor of reactive programming, but mastering CSP allows you to enter inside the reactive programming world very easily. So reactive programming, what is this paradigm? As you know, there are several different paradigms in programming world. So we have not just these three, but we have several others. We have imperative programming, where basically we are describing step by step what our application is doing, what our logic is doing. Then we have functional programming, where the interesting part of functional programming is basically when you have a function that accepts an argument. When you pass a value inside as argument of this function, the function will return exactly the same result every time. And you know for sure that that function is based on pure functions. This is a concept where exactly what I have just explained. And then we have reactive programming. Reactive programming is something slightly different from this tree here. Reactive programming basically is saying, instead of having a passive interaction where, for instance, the object A is calling the method of the object B because B maybe is injected through independence injection, it's saying something completely different. In this case, we want that the object B is reacting to some data that are injected inside the cell. But how these data are passed from A to B? Usually it passes through an observable, sorry. Observable, think about observable like an object, like a channel that you share across these two, and allows you to communicate and again manipulate the data potentially when arriving inside the object B. And we will see in a moment how it works. So why reactive programming is interesting? Reactive programming is used really by quite a few libraries at the moment. So on the top right, you can find a logo with a snake, and that one is basically React.js. It's basically one of the most famous currently library on reactive programming. Then we have another one just on the bottom of React.js logo, that is the Cycle one. Cycle.js is basically probably the second most famous library on JavaScript for reactive programming. Is basically leveraging a lot of interesting concepts. If you at the end of the presentation, I will share my GitHub account, and you will see if you have time, you can go there, and I prepare a few examples of Cycle.js. Then there is Bacon.js, that is another library that is using reactive programming. Angular 2 currently is using observables in order to communicate between components. And then we have Fuse, that is a startup based in Norway and California, that created, let's say, a new framework in order to create native application, and the whole framework is working with reactive programming. So there are quite a few things, and these are just some 5 samples about reactive programming, but you can find a lot more inside on the web. Reactive programming is basically based on 2 patterns. When you leverage these 2 patterns, you are able to understand better reactive programming. So reactive programming is based on the observer pattern, where basically we have an object that is called subject, that is containing all a list of objects that are interested to a specific notification. And every time that there is a change of state, the subject is notified automatically all the objects that are subscribed to itself. And this case is super easy to avoid hierarchy, understand, and maybe share this share the notification across the whole system, because basically every object that is interesting to a specific notification can subscribe. And also, if an object is not interested to a specific notification but to another one, can subscribe itself as well. And the interesting part is it will react only when there will be a notification that it takes care. The other things that is important to understand when we talk about reactive programming is the iterator pattern. In this case, it's a way to traverse a container, and it's very easy to understand because basically, when we have an iterator, we are checking every time that we receive a data, or we have a data, and we traverse the container through next method, and we check if there is a new, basically, if there is a new value available through hasNext method that returns, obviously, a Boolean value. When you have understood these two patterns, it's kind of easy to understand how reactive programming works. So let's say, let's do a small exercise. So basically what I did, I prepare exactly the same example that I did here in with CSP, but this time in reactive programming. This is made with Rex.js and ECMA 6. There are several other things that I can show you because more or less it's been a year that I'm working with reactive programming, and it's solving pretty well the problem of asynchronous data. So what I'm showing basically is exactly the same thing. So let me go here and activate example here. So this one is the example, sorry, here. Another example that I created. Let's see if it works. Here we are. So this one is another example that I created. This is made with pure reactive programming. So again, it's the same game, bingo. As you can see here in this version, I added also the different numbers that are called inside each ticket, just to diversify the things. So I called the number 72 in ticket 1, they called the number 72 in ticket 2, and so on. As you can see, it's working in exactly the same way. Nothing is changing. So the result is exactly the same. So we have two tickets, two arrays, and we are basically, there is an engine that is calling different numbers, and we are basically inspecting these tickets if there are these numbers or not, till the end of the game. So let's see how it's made in this case. So in this case, what we have is this. So we have the ball code system that we create here, a new instance. So we have ticket 1, ticket 2, and we basically are injecting inside the ticket not anymore a channel, but we are injecting an observable. That is this ball stream. It's a stream of data, and inside the stream of data, we are basically checking whatever it is. So if we go to ball code system, we can go here and we express. Let me show you because it's very interesting, this part. We express is exactly, see if I can tackle this easily. Okay, cool. We are expressing the same concept, but not anymore in imperative programming, but in reactive. This part here. So if you remember, we have start the system, and then we call every 3 seconds this method send data. In this case, we are expressing exactly the same thing. And what we are doing is creating a stream that through the Rx observable API that every 3 seconds is returning a number to call. And we say we want only 40 numbers. So every time, basically, this interval, this tick react to a second, what we are doing is returning a value that is retrieved by this array here, and that's it. And this value is basically stream inside this streams. So inside the stream, and that's really it. What we are doing inside the ticket, basically, because we pass the observable, is saying observable subscribe. So if you are interested on something specific, subscribe. So in this case, every time that I receive any data, I just check if there is this value inside my array. If there is, I add it to the total nums code, and I show this inside the console. And that's really it. Nothing else, nothing more. As you can see, it's way more simple to understand the whole flow inside this interactive programming example more than the other one. All these examples are already in my GitHub account, so you can check if you are interested on it. Let me move back to my slide. Okay, so when we talk about reactive programming, we have to talk about MVI. MVI stands for Model View Intent. As I said before, is an architecture that was made mainly for this paradigm. The interesting part, as you can see, is leveraging the concept of a unidirectional flow, like flux, and also is using something that is very familiar for us, the model, the view, something that is not very familiar, that is the intent. How it works, basically. So in this case, what we have is the view that is basically is using, if you try this, if you want to try this architecture, just use Cycle.js. Cycle.js is created in order to use also this way to construct an application. And in this case, the view basically is containing the virtual DOM and is passing the virtual DOM, so what they should be rendered inside the browser, through to the rendered library that usually is made with a third-party library that could be React, it could be HyperScript, it could be several others that are leveraging the concept of virtual DOM. And basically inside the view, we are just keeping the logic of what should be rendered. So then the intent is basically fetching from the real object, so the concrete objects that are present currently inside the browser, is fetching the events that are triggered by the user. So every time the user is, I don't know, clicking a button or inserting some data inside a text input, whatever, these, all the listener are inside the intent. And this intent is preparing the data for the model in order to, let's say, prepare the new state. And every time that there is an interaction from the user, the intent is passing this data through an observable again to the model. And the model is obviously retrieving the data from HTTP if needed, and manipulating the data, and is passing this information manipulated, so it's basically keeping the state of the entire application to the view through, again, an observable. So the only way to communicate between these four objects is always through observables. So we are not talking in any other way, and the only way to communicate, so there will not be any, let's say, communication through a public method. Is always working through observables, through streams. So the MVI rules. A model shouldn't control any other module. So like the controller that is controlling FMC, some implementation of FMC, the model and the view. The only part that is shared across this object are the observables, and the intent is the component that has only one responsibility. So you should understand what is the intention from the user and update the model accordingly in order to prepare a new state of the application. The pro, obviously, is a better separation of concern. We are leveraging the concept of monodirectional flow that is quite important, because when you scale, it's very interesting. Also, if you check in particular Cycle.js, is leveraging also another concept of fractal, where basically you can reuse a component on top of another component, and you can basically create nested component each other, maintaining an MVI architecture for each single component. That means it's very easy to swap one component and reuse in another project, because you are always using this unidirectional flow across these four objects. The application became very easy to test, and also that you know for sure that the state of your application is living inside the model, and it's the only place where you have to search if there is something that is wrong. The view is, again, state agnostic. So in that case, it means that you can swap view as long as it's injecting a new observable. So as you can see, there are a lot of pro based on this architecture. If you want to know more about MVI, this is the link of an article that I wrote for the newstack.io, where basically I'm explaining a little bit more further how MVI works. The last thing that I would like to talk about is when you should use CSP and reactive programming. So I see in the JavaScript community quite often the the thing of okay, React is the new hot topic, or Angular 2 is the new hot topic. Let's use everywhere. This is something that I discourage, honestly, because it's not the right approach for an engineer from an engineering point of view, where basically you should use the right tool for the right job. What I'm suggesting is, if you have, let's say, an application that needs to handle or be driven by backend, and your application should be just, let's say, a dump container that has, let's say, some logic but not that much, this is a perfect paradigm that you should use. So, for instance, I think Netflix is familiar for everyone here. So if you think about the interface of Netflix, all the catalog, all the data are handled by the server. So in that case, for instance, Netflix is using React.js, so it's using reactive programming in order to compose the interface of the main application. And that is an interesting thing, because it allows you to understand better that everything that is driven by some data, like a game, like I showed, like Bingo, from server, that in this case was simulated by my engine, it could be a suitable application for reactive programming. That's everything for today, also because I think that I'm running out of time. These are my contacts, and I